I
was saying to all the congruent ones.
Oh yeah, this one's congruent to this one's congruent to this one. I agree with that. I also agree that they have a shared side. Do you guys agree? And shared sides, you guys agree, are congruent to themselves? So there's a side in each triangle right here that's congruent to each other, correct? And we know that this angle is congruent to this angle is congruent to this angle, and this side is congruent to this side. But in order to apply side angle side, you need the angle in between the two sides, correct? So we need this angle and this angle. You guys agree? Do we know that these two angles are congruent? And the answer is yes. What theorem can we apply to prove that? Yeah.
Third angles theorem.
Very good. By the third angles theorem, we know that these two angles must be congruent. Who remembers what the third angles theorem said? What does the third angles theorem say? Kristen. Very good. If you have two angles that are congruent between two triangles, the last one must be congruent. Okay? Yes?
How come it says do it by the SAS theorem if it's by the third angles theorem?
Well, the third angles theorem proves that these two angles are congruent, right, Hannah? But in order to show that these two triangles are congruent, the triangles are congruent by what theorem? So now that we've proved that we have a side, an angle in between them, and then the other side, the triangles are congruent by what theorem now? John?
I was going to ask if I could charge my iPad.
By what theorem, Gio? Thank you. It's side, angle, side theorem. So Cody, ignore these two now. And just look side, an angle, and a side. Side, an angle, at a side. Now, Cody, I agree with you, right? At first glance, what was given, you couldn't use side, angle, side. But if you have two angles are congruent in one triangle, and they're congruent to two angles in another triangle, then that third angle must match up.
I got another question.
You got another question? Go for it.
All of them don't have to be like side on side, only just one in both?
Correct. Correct. You need to match up a side, an angle, and a side in that order in between both triangles. Okay? Let's take a look at the second one. We have to make two inferences here. The first inference we need to make is the same one we made last time. What was the first inference we made in the last figure? What theorem did we use? Yeah?
The third angle theorem.
Very good. The third angles theorem. So that means that this angle over here, right, must be congruent to this angle over here. Are you guys cool with that? Because these two, this one's 90, and this one has to be the same as this one. So that third angle must be congruent between the two triangles. Now we have this side and this side. Now be careful here. This double congruence mark here is only referring to this piece right here. And that is not the full length of the side. Do you guys agree? But let's just put 3 markings here, because that's a piece of the triangle that's shared between both of them. Do you guys agree? So how would you describe the length from the 90-degree angle to the second congruence angle? It's 3 plus 2, right? And how would you describe this side of this triangle? It's 2 plus 3, right? Wouldn't those essentially have to be the same thing? So we have side, angle, side here. Side, angle, side. So you would say these triangles are congruent. By the side, angle, side theorem. Bless you. Any questions? Okay. I talk specifically about two types of triangles, isosceles and equilateral triangles. We've already touched on both of these. What is an isosceles triangle, peeps? Yeah.
Where two sides are the same.
Very good. At least two sides. You guys got that? At least two sides. And what does equilateral mean?
They're all
the same.
What's all equal?
all the sides.
All the sides are equal, okay? So equilateral means all the sides are equal. Isosceles means just two of the sides have to be equal, at least, okay? All right, so there are different parts to an isosceles triangle, okay? Let's identify them. The angle that is at usually the top, but sometimes these triangles get flipped, so be careful of that, saying it as the top. The angle that's not a base angle is going to be called your vertex angle, okay? It's at the top of your triangle when everything's facing upwards. The two legs are the two sides that are congruent to each other. So these should have congruence markings on them. Put them on your figure, okay? And then we have something called base angles. The base angles are touching the base of the triangle, right? The vertex angle, does the angle at the vertex touch the base? No, okay? So this angle is going to be different than these two angles down here. These are what we call our base angles. And then your base side does not necessarily have to be congruent to the legs, okay? But the legs must be congruent to each other, okay? There's two different diagrams in here to help you understand, okay? But you do need to know 1, 2, 3, and 4 vocab words, okay? The base is that side on the bottom. The legs are the two sides that are congruent. And then your base angles are the two angles next to the base. And your vertex angle is the one hanging on top. Take a look at it. Let it sink in. Are there any questions on this diagram? Go ahead, Carson.
So like I get that the base angles are like two in the corner, but like the base, that's not like, that's just like I don't understand. Like that's not an angle, obviously.
No, the base is that side, right? So like I want you to draw another isosceles triangle. Make it really, really skinny so you can absolutely see actually, let's draw it upside down too so they don't all look the same. Draw it really, really skinny. And let's label this 1, 2, and 3. Carson, which of these sides would be the base? 3. Why?
It's like, because the vertex is like that one, so it's like the opposite.
Exactly. It lies opposite the vertex angle. And these 1 and 2 have to be our legs, right? Because there's no way 3 is going to be the same length as 1 and 2. Okay? Does that help you understand? Okay, what's up, John?
Is the leg like the line or like the outside?
The leg is actually the length of the segment. That's correct. Okay, so it's a side. Good questions. Any other questions on the isosceles triangle? These are good. Keep them coming. All right. An equilateral triangle is an isosceles triangle. Is that always true, sometimes true, or never true? Why is it always true? Juliet? At least 2, right? How many sides does an equilateral triangle have that are the same length? 3. Is that at least 2 of them? So all equilateral triangles are isosceles. Reverse it. Are all isosceles triangles equilateral? No, that one would only be sometimes, okay? Only sometimes does an isosceles triangle have its base be the same length as the other 2, okay? Now, this is the first theorem of this lesson, okay? It's called the base angles theorem. If 2 sides of a triangle are congruent, then the angles opposite them are congruent. In other words, your base angles must be the same measure. So if AB is the same length as AC, if those 2 segments are congruent, then the angles opposite those, aka the base angles, become congruent as well. So what I would like you to do is underline this statement in blue. That's what's given. We knew that these two legs of our triangle in blue had to be congruent. And then in red is what the base angles theorem says we can conclude, okay? That the base angles of this triangle are congruent. Draw congruence marks on your triangle to show that the base angles are congruent. So draw a congruence mark here and a congruence mark here. That's the conclusion that we're making. So as long as this triangle is isosceles, we know that those two angles are congruent. Which angle doesn't necessarily have to be the same measure? The vertex angle. And in this diagram, which angle is the vertex angle, guys? It's angle A. Do you guys see that? Okay. Another way students remember it is the vertex angle is formed by both of the legs, right? And the base angles, they both are formed by a base and a leg, right? Because this is our base, this is a leg, and this is a leg. Questions? Okay. The converse also exists. So the converse of the base angle theorem says if two angles of a triangle are congruent, then the sides opposite those angles are also congruent. So in this case, we're switching our hypothesis. Our hypothesis is now angle C is congruent to angle B, and our conclusion becomes our sides need to be congruent. Our two legs need to be congruent. So we're going to put our red markings on the segments AB and AC. Now, one connection I want you guys to make. What were the two triangles on the last two slides? What kind of triangles were they? What kind of triangles were the triangles on the last two slides? They were isosceles. So both of these theorems hold for isosceles triangles, okay? And it's true for all isosceles triangles. So not only do isosceles triangles have two congruent sides, they also have two congruent angles, okay? Their base angles must also be congruent. Got it? Okay. Name two congruent angles in this figure. Cody? Angle F must be congruent to angle E. Why? Why? John?
Because those two sides are congruent.
FD and DE are congruent, but why would that make these two angles congruent?
It just is.
It just is.
Yeah, I like that.
Try to use a theorem here. Sophia?
I was gonna say it's because they're both touching the base.
They are both touching the base, so these two angles are what kind of angles? They're the base angles. Now, is this proven by the base angles theorem or the base angles theorem converse? Go back in your notes and try to fit which one tells me that if two sides are congruent, then the base angles must be congruent. It's the regular base angles theorem. Okay? Both of these theorems and what they say and what they mean and their names need to get memorized, okay? Someone start making a Quizlet for chapter 5 and we can share it all together, okay? How would you label angle D?
Vertex?
It's the vertex angle. Why? Why is it the vertex angle?
It's where the points meet.
It's where the two legs meet. Very good. We Gucci? Which side is my base? FE. Okay. Are we starting to see how an isosceles triangle is formed? Okay. Corollaries. There's two corollaries that happen from these two theorems. The corollary to the base angles theorem, it says if a triangle is equilateral, then it is equiangular. And the converse to that is if a triangle is equiangular, then it is equilateral. So, what does equiangular mean? Do you guys remember what that term means? All the angles are equal. What does equilateral mean? All the sides are equal. What you guys need to know, you do not need to memorize the names of these theorems, but you need to know what they mean. If you're equiangular, you have to be equilateral. and vice versa. You cannot have one without the other. No triangle is going to be equiangular and not equilateral, and no triangle is going to be equilateral and not equiangular, okay? And I want to show you an example of that. After you're done copying down the blanks, I want you to draw this little triangle like this. And let's say I put a congruence mark on each side of the triangle, showing you that each of the sides is the same length. What would you say we were given as information about this triangle? What do we know about this red triangle? Cody? It's equilateral, okay? Now, using these theorems, what else do we know about this triangle? It's equiangular. More specifically, what is the measure of each of these angles?
60.
It has to be 60 degrees, okay? So anytime now you're given equilateral, it automatically infers it's equiangular as well. Anytime you're given equiangular, you automatically infer it's got to be equilateral. You cannot have one without the other. How are we feeling? Okay? Ready for the examples? Let's do this thing. Okay. We're going to find the value of x, and you see these examples. Take a look at A. First, identify what we know about the triangle. What do we know about this guy? The vertex angle is what? 30. How do you know that this is a vertex angle? Yeah, it meets at the two legs. But what kind of triangle is this? Isosceles. What else do we know about isosceles triangles? The two angles, what? What are about which angles are going to be congruent here? This one and? The base angles. Do you guys see that? So if these two are congruent, what does the measure of this angle have to be? X. Can you set up an equation to solve for x? What do we know about this triangle? Yeah, Kristen. 180 equals 30 plus x plus x. Someone else explain to me, what did Kristen just do? What did Kristen just do? Because she is absolutely 1,000% correct. But what did she do? Gio. Good. Is that something we can do for any triangle?
Yes.
Absolutely. All the angles inside of a triangle must add up to 180. Okay? So let's solve this. How do I solve it? Combine like terms, what do I get? 2x plus 30 equals 180. Then what? Subtract that 30 from both sides. What do I get? 150 equals 2x. Then what? Divide by 2, divide by 2. And you get x equals 75 degrees. Make sure you put that degree symbol. A lot of us forgot this on the test. You need to put measurements when it's talking about an angle, and it must be degrees. How are we feeling on that one? Are there any questions on this first one?
Could you zoom in a little bit?
Zoom in a little bit? Yeah. Is that better?
Yeah.
Okay, second one. Letter B. Any ideas? Grayson? Ooh, I'm glad that you said that, but I'm glad because that's wrong, okay? Adding all the sides together should not equal 180. Why? Why would adding all the sides together not equal 180? Grayson? They're not angles, okay? Do all the sides of a triangle add up to 180? No, all the sides could be different in a triangle, okay? All we know is that all the angles. Were we given any information about the angles? Kind of, right? Yeah, John, what? These two are congruent to each other. In other words, if we have two congruent angles, automatically, what kind of triangle are we dealing with? Isosceles. So now it's up to you to figure out which two sides are the legs. Which two of these sides would be the legs? German? 2x minus 4, and x plus 5. And if those two are the legs of an isosceles triangle, we know that they are congruent. So what do I do with those two values? 2x minus 4 equals x plus 5. And we solve for x. So you would subtract x, you get x minus 4 equals 5. And then what? Add 4 to both sides. And you're going to get x equals 9. It's degrees, right? No. Why is it not degrees here? They're not angles. They're what? Sides. You got it, Grayson? Okay. Do not fall for it. Don't just stick a degree symbol on everything that you're given. We Gucci. If you wanted, you could put units there, okay? But I'm okay if you leave it blank. If they don't give you units, you don't have to put them in yourself. Cool? All right. What's up?
Do we have to plug in the x for the base or no?
No, it just said find the value of x. Okay? If you wanted to find, what was the length of one of the legs then? 14. You should get 14 for both of them, okay? If you plugged it back in. That's a good practice, okay? All right, C. I want to leave C up to you. Try to solve it. Go. A little sneaky here because are 56 and 62 the same? No. So what do we have to do in order to solve this triangle? Find the last angle. How do you find the last angle in a triangle that already gives you 2? You add them together and subtract it from 180. So when I add these two together, do you guys agree I'm going to get 118? Subtract that from 180. What do you get? Say what? Do we have 2 congruent angles now? Which 2 are congruent? The 62s, which means what kind of triangle do we have? Isosceles, so the opposite sides must be congruent. What is x's value? 42. Ask me, Diana, what's your question? How did we get 42? Well, hold on. Hey, Cody. Shh. Guys, we got 42 because if we have 2 congruent angles, right? Then this has to be an isosceles triangle. And you agree that the legs must be these two? So 42 is the same distance as x.
Oh.
So we just set them equal to each other.
Okay.
Ask Hannah.
How is the bottom the middle?
Because this is like an isosceles triangle that's turned on its side. If I were to rotate it, right, and put this point up at top, I could do that. This would be 56. This would be 62, 62, okay? But you have to look at the triangle from a different perspective. Then this one becomes 42, this one becomes x, and this one becomes 41. We know that these two must be congruent. Did that help a little bit? What?
A little.
A little. Jeremy, what's up?
Well, the base was just 41.
The base was 41, yep. Okay, cross out the proof. We're not doing that. But we are going to do this one, okay? This is a proof, but we're just going to walk through it. We're not going to, like, physically prove it. You can if you want to, if that floats your boat, okay? All right. Given that M is a midpoint of AB, what does it mean to be a midpoint? Cody? It's in the middle. So if M is right in the middle of AB, what happens? Before we do anything else, what happens? What do we know about this line, segment? Yeah. Excellent. Those two segments must be congruent because M is the midpoint. Add it to your diagram first and foremost. We've taken one sentence and we've already applied it to our diagram. Then it says the measure of angle 1 is equal to the measure of angle 2. What am I going to add to my diagram? Yep. A congruency symbol for the angles. So look at the triangle AMC. AMC. What kind of triangle is it? How do you know? Not the congruent sides. Because we don't know, we only know one side in this triangle. Yeah? The base angles are congruent. Therefore, What other side needs a congruent symbol? AC, right? So if these two are congruent and these two are congruent, which two lengths have to be congruent by that logic? Yeah, John.
Wait, what?
Which two can we say are congruent? Because we're trying to prove this, right?
Wait.
We know that AM is congruent to MB. We know that AM is congruent to AC. Don't we know that AC is congruent to MB?
Yes.
Does anyone remember the property that's applied here? Hannah?
It's like transversal, like to the triangle.
No. Yeah? This is the transitive property, okay? Now, you're not going to have to know that for any assessment, but it is good to see what's happening logically here, okay? Because if I gave you the length of this is 7, you should be able to move that 7 over here based on the logic of isosceles triangles, okay? If you want to write it down, it was the transitive property. Grayson. The transitive property? No. I could give you this side is 7 and be like, okay, find AC, and you should be able to find it, okay? All right, last example, people. How can you solve for X and Y in this diagram? John, what's your idea? Go for it. It's okay to be wrong.
Is it Y like 4 as well?
Very good. Why does Y have to be 4?
Because it's an equilateral triangle.
Good. It's equiangular. That means it has to be equilateral. So Y must be equal to 4. How could we find X? Sophia?
X plus 1 is equal to 4.
How do you know that?
Because the base is congruent to that to ln. Like the base of k and l is congruent to ln on the other triangle.
You are right, but your explanation is not. Gio, can you help her out? Never mind. So, Sienna? Ooh, why is LN congruent to LM, Sienna? Oh, because this one's not congruent? I agree, but why? But why? But why? These angles are congruent. Do we see that? So, John, what kind of triangle is the one on the bottom?
Oh, that's an obtuse triangle.
It is obtuse, but more specifically.
Um,
I want to know about the sides, people.
the sides are both congruent and x equals 3.
Okay, so the sides are both congruent and x equals 3, but why? Bryson? It's an isosceles triangle. Okay? If you didn't know that it was isosceles, you're going to get this wrong, okay? Because now we know x plus 1, we set it equal to 4. If you're just blindly setting stuff equal to each other, okay, stop. You need to understand the why, okay? So we set x plus 1 equal to 4. You subtract 1 from both sides, x equals 3. Questions on this one? Okay, turn these in. We're going to play a gim kit for